Hey, I'm me313. I just wanted to follow up a little bit and a little more information on what we were talking about today, where there was kind of those two subtypes in the multi-stage vapor compression refrigeration. I want to kind of compare the two. What I'll do is I'll use that example we did in class today. So just to remind you again, here's the example we had in class today. And we had our high pressure at like 1400, our middle pressure at 500, and the bottom pressure was down at 120. So let me just come over here. I'm just going to kind of cut to the chase. Here's the problem that we solved today, and I've just got it here in EES. So I'll go ahead and post this so you can look at this file. This is exactly what we did. But if you remember, we went down and we saw that our fraction y that was being divided at that flash tank was 0.29. And we calculated the net work and the heating capacity. And then in fact, the one thing we didn't get was just the coefficient of performance, which is the ratio of those two, and it's 2.72. All right, so that's the problem we did today. But what I want to come back to is contrast this with that other subtype. And remember, that other subtype, effectively, we're taking those two components and replacing it with just a flash tank. And what we're actually doing is it's sort of like we're mixing and then flashing instead, because if you look at what happens if you use a single tank here, you're taking streams 6 and 2, you're mixing them first, and then you're pulling the liquid off at 7 and putting that into the expansion valve. So it's a little bit different, because effectively you're, instead of taking the output from 6 into the valve, you're mixing them first. But that's only kind of the subtle difference. And so we can actually go ahead and just slightly modify our EES file, solve this, and see how we get a slightly different behavior in our refrigeration system. So I'm going to come back over here to EES, and we'll show you what needs to get changed. And what we've gone down here is where we had that mixing chamber, this part of my code right over here, where we said the fraction y was going to be the quality at 6. Now that's not what actually the fraction y is. There's actually no y in this. Remember, there's no middle stream there at all. So actually what we're going to do is we're going to actually remove that specification of y in that energy balance. The energy balance can be a little different. So I'm just going to go ahead and put this in here, and then I'll quickly explain what we're doing, and hopefully it can become pretty clear. So what we've done, this top equation here, is I've got the energy balance. Notice I've got 6 and 2 is becoming 9 and 7. So if I come back to my diagram, right, 6 is coming in at the top, and 2 is becoming 9 and 7, right? And then we're waiting 2, there's just the fraction 1 minus y. So what I've got down here in the bottom is still the fraction 1 minus y. All right, and so effectively what that means is you can kind of think of y's in that middle component. But we're going to go ahead and just go ahead and solve for that. So that's all that is. So the energy balance is different. Got 4 terms in here. And then this equation is going to solve for 9. And then I just want to tell EES that's actually equal to the enthalpy value where x equals 1. And the reason we do that, if you come over here, remember, 9 now, we've now pinned 0.9 onto the right-hand side of the curve. It's a saturated vapor. Whereas before, 9 was kind of be able to float out in the superheat region. Now we're pinning 9 there. So if I come back over here and solve EES, I'm going to get slightly different numbers. Let's look here what we see. Notice now this fraction y at 0.31, I mean, there's not really a y, it's just that 1 minus y is going through the bottom, which is what we had last time. So you can think of it as this is just the amount of material going through the bottom, and there's actually less material going through that lower loop. And you notice your coefficient of performance is slightly different as well. The QL and the W's are just slightly different, not a lot. Last time we had, it was a 2.1, and now we got about a 2.7. So slightly different. So anyway, I'll go ahead and post the EES file if you want to take a look at it, but hopefully that kind of shows the subtle difference between these two subtypes of multi-stage refrigeration. All right, hope that helps.